Hello, it has been a very long time since I've done this. A lot has happened. I have moved. I have got a new job. I've done lots of things since I've last done this. And I wasn't joking when I said I was going to be coming back in December. So, kept the same glasses though, which is good. But yeah, a lot has changed. I'm in a different place, so it's a bit weird. But anyway, this is called Farming for Binaries. If you want to find more content that I've been doing, I actually went to a conference recently. So if you go on the Hacktivity, H-A as in hack, I should say. This I'm not making sense already. Hacktivity as in activity, but with hack. 2018, I did a talk on reverse engineering pub quiz machines. I've got a talk on reverse engineering pub quiz machines on this channel, and I did further the research which looked at other parts which were really, as I usually say, interesting. So if you want a little bit more content, then you should absolutely look there. The content I've got for you today is called Farming for Binaries, and it's something that I've looked at before and thought I'd just give a preview before I look a little bit further into it. So yeah, that's their main aim today. I'm going to go straight into it. There's loads of different things that I could talk about today, but today I want to talk about having the ability to dynamically change binaries and evade detection. So there's lots of antiviruses and malware developers that do this already, but I'm going to show it being done publicly. So there's that. First of all, as well, I'm not going to be showing actual malware, because I can hear people already saying, why are you already showing malware? No. That is not happening, don't worry. I have got this small script that we will see in a moment. But what I want to do is I want to automate in Python so that I can change things easily. So I actually have seen some threat actors doing this. And so it sort of inspired me to look a little bit further into it and see how they did it. They did it quite a little bit easier by just changing a few bytes. But I want to see from a more sophisticated level, because I'm sure there are threat actors that do that. So, wait, isn't this just crypting? Well, I mean, there's different ways of seeing it, but basically the aim is for me to intentionally break the flow, making it harder for the analysis to read. I'm not actually trying to make this fully undetectable. What I'm trying to do is making analysis much harder, so that if you have anti-detection methods like anti-VM or checking if Wireshark is running, making sure that actually the analyst is trying to find that is actually quite hard. Let's say you had like crypted strings or made it harder for them to read. The actual functionality is also obfuscating, making it hard. So yeah, it is crypting, but there is a whole lot more to it than just, oh, we're trying to evade detection. There's a whole lot more that I'm trying to convey here. So why do this? It's a good technique to learn. It's good to understand, and it's actually quite interesting to sort of look at how analysis tools cope with whatever. I've been doing it for a little bit, but I want to talk about like the most simple example that I've got. So it's good to learn as a pen tester, obviously, but it's also good to understand from an analysis and blue team perspective, because you sort of get to see what the attackers could possibly pose. So do actual threat research and attack research to actually look at the forthcoming of what someone could potentially be looking at. And it's also technically challenging, so there is some good parts to it where it actually sort of challenges you to find new examples and new ways to defeat tools or change the way that people perceive and do analysis. I mean, obfuscation was a really good technique that someone showed, how you could use MOV assembly instructions to basically obfuscate a binary, and that was really good. The output was really large, but it's such a technically sophisticated example of something that can make analysis so much harder that a normal everyday analyst in a SOC or someone that reverse engineers APT may not be able to understand what this actual binary is doing. It's just simple. It's just making sure that we connect to a web request. It's just a proof of concept. It is. I'm not downloading anything. Obviously, you could check the receive, download something by interacting with more of the API. But as I'm sure people are going to say to me, oh, this is unbelievable, you're distributing malware. It is just a simple HTTP request. But I do know that lots of people love seeing code. So there's the code. It's wonderful, isn't it? The buffer's 1024. Pretty standard. Nothing really I need to explain looking at that. You know, it gets handle and stuff like that. There is a while loop, so that's real great. No, there's nothing there that I want to explain. First indicator of maliciousness. What am I saying on this slide? This is, as you can see, I'm super prepared here. Yeah, simply what I'm trying to say is this proof of concept code, you could have a loader. So loads of different code from malicious actors use loaders. They all have very similar but different ways of doing this. So obviously you don't want the bare minimum internet URL request, load it, shall execute, because that's just going to be detected straight away. So everyone has it in a different way, but this could be the easiest option, is to create a loader out of this. You get the response and you write it down, or you put it into memory and run it. I'm not going to develop a fully featured backdoor because, as I previously said, it's just not going to work out. So yeah, one of the things I thought about was looking at this complex conditional. So as we can see from this screenshot, there's some really crazy stuff going on in this code. And what I've done is I've sort of randomized some if statements and then put some more conditionals in. And it's basically just junk code, but it's making it harder for the flow. When you put this into idle, obviously it's much harder. And this isn't static values. This is randomly generated from a Python script. And I know this is me manipulating the source code, but soon I'll look at how I can change the actual bytes instead of actually going into from an assembly level, instead of going into it in a C level, because you might be able to actually just change anyone's binaries and obfuscate them in that way. And that's what a lot of crypting services do, and that's what I want to look at more and more. But one of the things I'm looking at here is how I can change, one, the file size, two, the way that conditionals are put, and three, how everything looks when you're trying to analyze this code. So on VirusTotal, this might be very different in analysis, like in a sandbox or something, because of this. And you might think, well, that's a conditional, but actually these conditionals may take a large amount of time compared to other conditionals or the original program. So that's really important. We've also got inline assembly as well, but I think I talk about that next. I don't know. But yeah, there's some complex conditionals where it's just, in either it's craziness, you can't see a thing. So at the moment, yeah, the problems with the Python script that I'm doing at the moment is I have limited inline assembly being used. I haven't got a whole library. I haven't researched thoroughly yet. It is literally me just doing some decrement, increment, sub EAX, as we can see there. Not anything too interesting at all. So it's definitely, I've definitely got to progress it, but it's got some problems with it, this script. Obviously, it's me sort of exploring the idea and stuff like that, but nothing too out of the ordinary. Conditionals don't enter into new functions, which make it much harder. So obviously, it is all just one function, and as we can see, so here, this is all just junk code here, and then we've got one line of actual code, which is why I've got this red box circled here, and then some more inline assembly and then more junk code. So there is so much conditionals in inline assembly before another line happens, which is what I'm trying to perceive there. So what would be even better is if these were in a function and making it sort of like a cave where it was harder to find actually one line of code. So one of the things previously is I've seen malware developers using sort of like a virtual machine in quotations, and you know that the concept of a virtual machine and opcodes, it's kind of abstract, but thinking of that from a functional call sort of point, where you get a line, you interpret it, and then you go into a sort of cave, as I'm talking about inward recursively going into these functions. It's like a virtual machine almost, because of this sort of complex sort of mechanism that you have to follow the code in a debugger to actually find the one line of code that you have. And when you're looking at the virtual machine sort of obfuscation techniques, there is, you know, you're trying to find that one line of code and that one line of opcode that is actually in the interpreted function of what it wants. So that's the next sort of step that I think should be done when exploring this subject, at least. It doesn't read or reuse too much from original source. So there's totally things that you can pull off other people, other lines of code, to make it much harder. So we could, you know, put like if hinternet equals and then something else, and it's still junk code, but it's using it to change how an analyst might have to look at it. Sort of a red herring or a false flag, like most people would call that. Pretty dumb conditionals. These are random numbers in a certain range that are being checked, and there is always in one of these the right number. So these will return. Oh no, wait, they're not. No, what am I talking about? These are all wrong. This is why they don't return, because they don't want to return. They want to go through the code still onto the next line. So all of these are just randomized numbers and are pretty dumb. So if you're an analyst, you can probably cook something up in Python, IDA and sort of change it up. So that's something that also you need to look at. Is although graphically it's quite hard to look at, and actually with IDA out of the box it's quite hard to find. Actually, if you have an analyst, after a while they can actually just automate the process after they notice that it's just one line. And that's the thing with the process of reverse engineering, the amount of examples that they get, the tests that they get. So it's more like a scientific sort of project where you test what you're doing if you have no idea what you're fucking doing. So yeah, that's also a problem if you're looking at it from an obfuscation point of view. So polymorphishism is what I'm saying here. This is some of the lines of code, and this is the if statement. So as I say, there's some randomization and an if, and we're using some for loops. This isn't the whole thing as well, and this is also the library of inline assembly instructions that I've called mnemonics, I think. If I'm MNS, I'm hoping. But yeah, this is some of just the code of polymorphishism, where you're changing it completely. Every run, you are changing it. And that's really what I'm going for here. Whether that's actually quite correct, everyone's going to look at my code and judge me. I know this already, but that's just a little portion of what I was trying to look at. But the idea of automating a C binary with Python to change the way it looks is actually not a new idea. It's totally not. But actually, people don't actually publicly explore what they're doing and presenting it. They just talk about the cool techniques that they've noticed, and I think it's really important to sometimes outline that. So yeah, a little wrap up of what the actual script does. Obviously, it develops a template from source code, and then it manipulates the source code in a certain way, outputs that, compiles it, and then you've got the finished binary, which is really great. It's obfuscating-ishism, it's polymorphishism, it's really dumb, and it's quite simple. But for the first video, I thought, it's kind of interesting to talk about, is the idea of actually automating C binaries or C++ binaries and their source code to change it up, because that's what's happened. And then the next level that you would go for is the bytes, and obviously understanding the interpreted bytes and actually disassembling like a normal disassembler, where you would do a linear disassembly, to try and understand the conditional statements and try and change it up to break it for what you want. And that's something that's really interesting, and maybe the next steps, which is what I'll kind of like to look at soon. It uses randomness, which is obviously really cool. Conditionals to make choices, that's really great, but it's actually really dumb at the same time. And obviously it uses inline assembly, so it changes the sort of function in some way in the inline assembly as well. But after a while, because of the limited library that we have of these assembly instructions, then you can say if there's this combination, we can remove them from the actual binary. So it's not great, but who likes writing in assembly these days? It's I sort of do, but it's not fun. It is fun, but it's not you're always in pain. That's how I'm going to put it. So yeah, in IDA it sort of breaks. There's 1,000 nodes in there, so it's not going to be great. Can't analyze it. You have to do it in the line code format, which is great. Loads of people hate that. There's no graph mode. No one likes no graph mode. So we do conditionals in nearly every line of code. So looking at this is disgusting, isn't it? You don't want to see this on your day job, or if you love analyzing malware, you don't want to see this. So none of this. Oh, we've got a helicopter outside. This is the problem. This is the problem with moving. I'll wait. Okay, I think he's fairly gone. So yeah, none of this code here actually is responsible for, I think it might be the jump or the move EX into 0, but all of this is actually just junk code. All of this, it's obvious, but actually trying to look at it in some regards, it's so long, the conditionals, trying to scroll and trying to find every line that's really interesting is actually quite hard, especially if it's not as obvious as C++. If it was assembly, you could definitely, and that's where I was putting into the point of virtual machines and stuff like that, it is the exact same. Over information, that is what I'm going for here. It's nothing new. loads of binaries before. I've imported hundreds of APIs to make it much harder for you to understand. Nothing new, but actually a really good technique to sort of throw off an analyst. The problem with it, obviously, the bin size, but actually this bin size is about 400 kilobytes from what I remember. It's completely different from obfuscation, where you would have, you know, just like ridiculous bin size differences. So yeah, the original binary was 385 and farmed binary was 435. And I don't think I've actually explained what I meant by farming. Basically just trying to manipulate loads of binaries and outputting them at any point. So it's sort of like just a repeated process. Farming binaries is something that I call it, but I don't think anyone else calls it a binary farm. But I do. I find it funny. It's not bad, the actual output difference, but it's still, you know, it's not ballooning yet, but it's because there's not many features and it is a couple of lines of code. So next time, overcomplicating functions. So actually, as I said, going into a function and recursively going into it until you get that one line of code. That's really good. Breaking IDA flows manually or automatically, super good idea. Really fun as well because it actually throws off so many people. Making conditionals count. Now that's really important because at the moment it's a really dumb logic. It's basically over information, but can you actually make conditionals harder so that like symbolic execution takes so much longer? It takes a much more exhaustive process to look at it. Essentially making analysts cry 101. That's what I want to do next, because it's fun to do and it's fun to explore. I think that is my last slide. It is. So that is the video for today. Hopefully you guys enjoyed. I do talk fast, so enjoy that. But yeah, it's been a while. Hopefully you enjoyed that conversation, and hopefully I will have content soon. I did say I would release something in December, and this is what it is. So enjoy it. There will be more content soon, hopefully. I am working on it. Thank you very much for watching, guys. I'll see you in a bit.